Yeah, already answered.
Answered. That's all. You take it up. Very
Yeah, I
few.
think we are online. Hello. What are there any questions online? Otherwise, we can start.
Yeah.
answering.
So there's a hello and are you back?
Yeah, I think we are back. We are online.
Okay. Hi. So welcome to this live session. So I've just addressed some of the questions we have received. Somebody has asked, recommend a work plan for unsupervised learning. We have a few lectures on unsupervised learning coming up. So in the following
Next
week,
couple of
next
weeks.
couple of weeks. So that will be a good starting point for you to learn. So somebody had requested that we have slightly more elaborate answers for some of the assignment questions for better understanding. We appreciate that. Ambiguities in the assignment question should be. This is nice. I think I understand the concern to some extent. It'll be useful if you just post specifically which questions you want answered on the forum, and we can actually provide, and it will be helpful for everyone also. If you think that it's ambiguous, maybe there are other people also feel the same way, and we appreciate if you post exactly the questions for which you feel are ambiguous, and we will answer them. Not an issue. Why are the text transcripts not being updated? They are in process, and it will come up soon, hopefully, and so we they're being done. That's all. So there is a question about the inception layer. We have already addressed it. So there's another question about if you have a very deep pre-trained network like AlexNet for transfer learning, isn't it very probable that it will overfit our data? How do you avoid the same? So if you
Yeah.
the idea is if you use a pre-trained network, and let's say for the task at hand you have very few data points, so you have to define what very few is. Okay. Typically you don't retrain all the weights in the pre-trained network, right? You will freeze, you try to freeze, or you use a very low learning rate. Well, that is a problem. So you typically freeze most of the weights and you train a very small set of the weights, especially the one in the output layer is what you train typically. So yeah, if you have a very, even if you have a very deep pre-trained network and you have limited data, you try to train from scratch. Yes, it is possible you will overfit. I agree. Can I create a lecture or PowerPoint for relevant research on learning the right hyperparameters themselves through machine learning or analytical methods? There are techniques that exist in literature. We will point it out to you. I'll put it through announce. But it's not like a blooming field. I would think that there's very limited, at least to my knowledge, literature on that
Essentially,
subject.
AutoML.
AutoML is one such effort, I think, by Google.
Yes.
AutoML.
But it's an open problem.
It's an open problem actually. So we will try to post some material on that because it's not something that's been well studied or knows definitive conclusions there. But yeah, such efforts are in progress. So that's a good question. Can you please explain the mathematics behind data dimensionality reduction algorithms like PCA? We will have PCA explained.
So either next week or the week after that.
Either next week or the week after that, we will deal with PCA. So I think I did give a short introduction to it when you talked about data pre-processing techniques, and I kind of deferred it to a later. We will have that in the next few couple of weeks. One of the lectures will have about something about PCA. So that's all I have from the questions that were printed out. That
if people have questions, you can post it online. Somebody has asked resources where we could practice. We have mentioned this before. Kaggle is a good resource.
That is a good resource. I think
at the end of the course we'll point out a few more.
See, Google Colab is now giving some access to GPUs and what they call TPUs for free. So you can try to import data from Kaggle onto your Google Colab account and maybe use that. That's one of the better resources out there in terms of a free resource for compilation and running of your codes.
Somebody has asked, would you provide MATLAB in the final exam? No, it's not required. So you'll not required to do it. the assignment would be such that you can calculate using a calculator which is available, right?
Yeah.
It will be
Yeah,
available in
it'll
the
be available
MCQ
for
environment,
exactly.
or you can calculate it by hand. So those
Calculate.
would be the type of questions that you will have.
Yeah.
So we are not going to have any MATLAB specific questions in the exam. You might have some algorithmic questions,
Yes.
but that is not dependent on any specific language.
So it's a computer-based test. So there are constraints on what kinds of questions. We can't ask a programming question. Basically, that's what it is in the end.
So what did you just mention about auto ML? Somebody asked.
So AutoML is so the question that asks is there any specific machine learning technique for actually determining the best parameters of the neural network for the given data?
Yeah, hyperparameters.
Best hyperparameters, like how many layers should you have, what kind of architecture should you have, so on and so forth. So AutoML is a technique which determines that for you given the data. So it's actually machine learning which to determine the best parameters of your machine learning algorithm. So that's the thing. You can just Google AutoML, you'll get to the website and papers regarding that. That's all.
Again, there's a question about transcripts. So
being
transcripts are not being, so just to be clear, the process is that transcripts do not get processed directly by IIT Madras. There is a vendor who this goes to, and we do not have direct control on how long they take.
Exactly.
But after they come back, we verify, and after that, it takes some time. It takes us about a week after the vendor gets back for us to give you the transcript. So that's why it's getting delayed, because it's taking time for the vendor to get back to us. So that's where the bottleneck is. It's not at our end. So somebody has somebody is asking if, let's say, somebody is fitting linear regression, is there any way to extract the important features, and they don't want to fit on all the features?
Yeah, I mean, you can, well, for instance, one thing you can do is you can do PCA that decorrelates features, and you can, but I haven't talked about PCA yet. So that's one way to do dimensional reduction, also to get rid of the what do you call the redundant features in your data. So that's one of the first techniques that come to mind. Or you can just just from eyeballing or just doing correlation plot across pairs of features, you can remove features that are correlated. Okay, so that's one way of, so the uncorrelated features are the ones that are most important. I mean, at some level that will be the best way to do.
Okay. But then PCA boosting, all those techniques are supposed to help you a little bit.
Yeah.
If some feature has very low weights in general, you kind of eliminate them. There are multiple heuristics for this. No one single answer. What is this? So somebody has asked if there are errors in papers, can you point those out? In the AlexNet paper, etc. Also, there are a couple of errors. Sometimes we remember to find it out. If you find a discrepancy, please post it on the forums.
Exactly.
We can tell you whether this is an actual discrepancy or you just made an error. So, but that's a good point. We will try to do that as far as we are aware.
Exactly.
But if you find anything, please do post it. It's a good value addition for both us and for the course. Yeah. Then we can check whether there is indeed an error or not.
Yeah, papers could have errors because some of these papers might not have gone through peer review. I think the version they're looking at.
Even those that do
will have that. Yeah.
It's just how to train. Somebody has asked, can you explain capsule networks? That's beyond the scope of this course. But hopefully, once you have gone through the course, you should be able to understand the paper.
Yeah.
So, how to train if the dimensions of the features are different from sample to sample? Now, traditional neural networks will not work. So, if you have different features for different examples, then it simply is not going to work. You will have to choose, the minimal number of features. That's the simplest thing to do. Yeah. So especially for engineering problems. In the LSTM, in the RNN lectures that are going on right now this week, if you have the same number of features but different lengths of samples, you can kind of use RNNs, especially if this is sequential data. That's what you can do with RNNs.
If you are talking about missing data, I mean, they are all the same sets of features, but some values are missing, then you can try to interpolate or disregard that feature for all the entire data set. I mean, that's the typical practical solution, the only solution you can think of.
Yeah, but if you give a specific example, we could probably talk a little bit more about what could be done in such a specific case. So somebody has asked which book is better, Elements of Statistical Learning or Deep Learning book by Goodfellow.
Yeah, Elements of Statistical Learning is more like so it's written from a statistician's point of view. It's a very good book, especially if you don't have any background in the subject. It walks you through most of the techniques in a very simple
the elementary techniques.
Elementary techniques. I wouldn't say simple because it's actually a slightly advanced textbook. There is an introduction to statistical learning, which is slightly more accessible textbook at all levels. That is also free. It's online. I urge you to go. This is ESL. The other one I'm talking about is ISL, because the language in ESL might not be accessible to most of you. The techniques are elementary, but the treatment is very robust, and you need to have some knowledge of mathematics to actually understand the text. I urge you to first read ISL, and it actually talks about most of the modern machine learning techniques that are now being used extensively in data analytics and machine learning. Yeah.
Goodfellow's book is a proper machine learning textbook. ISL is a statistical learning, data analysis, data analytics kind of book. So Goodfellow has CNNs, RNNs, etc., which you will not find in ISL. But it will cover the statistical basis and the mathematical basis very strongly. So it's basically two different schools of thought. It's a marriage of these two that's going to exist in the future, hopefully. So there is a probabilistic viewpoint, or statistical viewpoint, which ISL takes and ESL takes. And Goodfellow's book is very practical. Okay, so even though there is some mathematics there, it is a very dense but practical book. How you can,
Goodfellow summarizes the more recent developments. That's one of the things.
That's right.
Yeah, the ISL covers more existing techniques, but in a very deep manner. Yeah. And it's accessible. ISL is accessible. ESL, the elements, the book you said, is kind of difficult to read if you don't have the background. That's it.
But both these books don't cover too much of neural
networks. Might not be. Neural networks might
not be. So deep learning won't be very. So that's a small section. Yeah. It's sort of focused on. Goodfellow's book is focused on deep learning. Yeah. So generative models.
The next few weeks will contain the topics that are covered in ISL and ESL. So you can refer. Yeah, the next couple of weeks will do that, and you can use that book as a reference. That's a good reference.
Now there is this question of, can you explain the math behind the algorithms? That's what we did in the first 3 weeks. Yeah. So please do check that. And we are still keeping the mathematical level of the course slightly low. We are not giving too many proofs, etc. If you are interested in greater detail, as we have mentioned several times, Goodfellow's book is a good book for that. But even that will be a little bit terse. Yeah.
Is there some paper I promised? That is not there yet.
So a few people are asking about some recommendations for transposed convolutions, some sources.
There is one paper I put up online. There is one. It should have been announced on the forum, a general announcement on the forum. There's an excellent resource on transposed convolution, in general, convolutions and operations in CNN in general that I've put up. Please look it up. If you can't find it, let me know. I think the TAs will probably point out, is there a link? Can you find a link now, or is that something it's very hard to do? But it's there on the forum. Please, it's on. I made it. I think they put it on a general announcement. Check it out later. We'll send you a link. Please post the question again on the forum. We'll send you a link. It's not a problem. Or I will ask them to put it on general announce. Okay. There's a general announcement on the forum. I specifically asked them to upload it. So there is an announcement. It's put up, right? Is it put up in a particular week or in a? It's in the general announcement. General announcement should be there. Please check. Please check your forum general announcement.
So one person has asked, how can CNNs be used for non-image data? This is a recent sort of usage, but for this course, we will only be looking at image data. What you're asking about is very recent. Some language tasks people are using CNNs, etc. But a priori, the first kind of use for which CNNs are best is normal image data only. Yeah. So that's where they perform the best. Some people are finding out recent uses also. Again, our hope in the course is all these advanced uses you can hopefully read by yourself and understand.
Yeah, exactly. Yeah.
If you are not able to understand these things, it means that something in our course has not been clear to you. So that you should clear for yourself very first.
Yeah.
Okay. So it is to make you capable of doing these things on your own, which is why we are giving all this information in this course. ASR for Indian local languages using MATLAB. No, I do not know anything.
ASR.
ASR, I don't know what it means.
What is it? OCR or
ASR.
Script recognition, no? Something.
Asian script recognition. I'm
Yeah.
not sure.
So we are not sure about. We don't have the background to answer that.
Also, just to clarify, remember the language models, etc.
Yeah, exactly.
We are doing an engineering and science application course, not the typical, and that's the speciality of this course also. So for those things, again, please read the papers yourself and see. And specific things like how to do this using MATLAB is something beyond what we even know. So we are not MATLAB experts by any means. As research goes on, scientists may achieve effectiveness with more and more layers in a network. Do you think there will be any limitation? There are theoretical limitations. Most probably, we are going to see something different from neural networks maybe in 10 years, 15 years time, or maybe even earlier. People are trying. There's a lot of researchers working in this area, trying different architectures, different ideas. So something might come through. So the limitation is already, how much can it express? You cannot dump a very, very large network on something and expect it to be interpreted very properly. So that limitation is already there. So I think at some point, already machine epsilon, as I have pointed out, is a problem while you train deep layers. So you will get very small gradient flow. It will become very hard. It becomes more or less useless beyond a certain number of layers. People can't keep on dumping larger and larger layers. You have to do clever things. Our hope, again, we repeat this every time we come online, is that you have some domain knowledge of the area in which you want to apply machine learning. It's a combination of that plus machine learning that will help you. If you are probably going very, very deep, it means you know next to nothing about the area, which is not a good idea at all. So once again, somebody has pointed out about the text transcripts. Like we have said, even week 2 text transcripts came back from the vendor only last week for us. So we need to go through that to make sure that the text vendor doesn't know the material. So we have to check that, put in the formula. It takes a lot of effort for us to put something. My guess is week 2 and week 3 will be with you. So it has gone up from our side, so it should be there with you maybe in the next week or so, or probably this week itself, maybe tomorrow or day after. So what is the minimum number of training images required in practice to train a CNN with transfer learning?
I don't know whether there's such a hard and fast number for it. Depends on the size of, it all depends on your problem. Okay, so it's a hard question to answer. Okay, it's very problem dependent, is my opinion. People have tried it. For instance, there is a network called ChexNet. I don't know whether you guys have looked at it. It's used for analyzing. You can look it up. Okay,
we should put it up also.
We'll put that up paper too. We'll put that paper up too. It's for analyzing chest X-rays. Okay, so that network was pre-trained on ImageNet data. Okay, you should look up. If you don't know what ImageNet is, look it up. And on top of that, this ChexNet database had, I think, more than 100,000 images or 1 lakh images, and it was pre-trained on. And then after pre-training, it was fine-tuned using that. So, but then is 100,000 enough? It's very difficult. You only have to judge based on your generalization performance. Okay, so it's a data dependent is my answer to that question. So sometimes it might work. That's up to your judgment.
Also, it depends. All these questions depend specifically on what kind of accuracy you want. Dr. Ganapathy has discussed bias variance. So there is always a trade-off. You use less data, you'll get a lot of bias, and then it also depends on what kind of variance you want, what accuracy is acceptable to you. If you are going to use one type of image and the transfer learning is to a very similar type of image, it's obviously going to work better. So it's very problem dependent. Again, the reason for discussing the theoretical background for all this is for you to get at least an intuitive idea of what could possibly be going wrong. You use something like ImageNet data on a chest X-ray. Obviously, there is still a lot of difference between the two.
Exactly. Yeah.
But if you use ImageNet data on something else, like to analyze the type of birds or something, so that you can expect that when something goes wrong, it's not probably because you had too few examples or something. So depends on the type of problem. how to handle uncertainty in deep learning. There is Bayesian deep learning. Unfortunately, we won't have time for this, but we will talk about Bayesian for and MLE and MAP.
Yeah, exactly.
For parameter estimation. So you have to basically treat it as if the weights that you get in a network are simple parameters, and those parameters are uncertain. Okay, because even though all that we have been doing, we have been treating all the weights we get, W's, as if they were clear, one number that you have to get, which is sort of the best fit. This best fit itself has a range. Okay, so instead of saying that this weight is 1, you can say something like it will lie between 0.9 and 1.1 with probability 0.95. That is the kind of thing that Bayesian deep learning will do. That is beyond the scope of this course, but we will discuss Bayesian learning in the context of linear regression.
Yeah.
And once you do that, that should give you an idea, since linear regression is just one form of function fit, and neural network is another form of function fit. You can think about, extend this to how uncertainty parameters can be handled.
A brute force way would be to have multiple networks. You can average and take a standard deviation. You can also estimate, let's say if you're modeling your output as a Gaussian, you can estimate a mean and standard deviation for your outputs. I mean, that is a possibility. Of course, you have to feed that as part of your loss function so that you can estimate them understandably, meaningfully. There are many, again, we'll try to put up references for them because there are many efforts in that direction. I mean, that's, like I said, that's where, statistical machine learning and this machine learning meet. Because, like you said, you would like to have some estimate of uncertainty on your outputs. And that's where statistical machine learning will help.
So somebody has asked example case study where ML can be applied in networks domain. I do not have any idea about networks domain at all. Whatever I say will probably sound hilarious to you because I'm just going to just guess randomly. Much better for you to notice the fact that you can map anything to anything.
Exactly.
And which is why we are repeating, you need domain knowledge. If you know the networks domain, and if you have understood the course so far, you should already have been able to see 3-4 places where it can be applied. If you cannot, then probably one or the other is lacking. Either you do not know sufficiently about the networks domain, or you have not yet understood. Actually, whatever we have covered till so far is actually sufficient for you to find applications in practically any domain that you are working. There are a few exceptions which we will cover in week 12, but within deep learning, you should be able to use. What we will discuss in the next 2 weeks are alternate techniques to deep learning. But the techniques we have so far are self-sufficient to be applied in any domain, in engineering or science. If this was not clear, then maybe something we said was not clear. Please review the material. Or please review what your networking problems actually are. Okay. Somebody has asked about robotics. The same answer. You can use it, and people are using it. There is something called reinforcement learning, which we are not dealing with in this course. That is an additional use. Those are for control strategies. So if you have any problem where you need control strategies, reinforcement learning is a good thing. But even otherwise, whatever we have discussed so far is usually sufficient. Somebody has asked, what else? Are there any mini projects? No. It's too far beyond our logistics to handle any mini projects. 2,000 people are registered just for the exam, and 20,000 are registered for the course. So obviously nobody can look at the projects. And if we are not looking at the projects, then there is no point in you doing it. Much better for you to go once again. You would have seen in week 7 also, we started giving assignments where you read papers and give answers. Much better for you to go online, look at something that looks like an interesting application to you. Okay, so somebody has some face recognition software or something. Many people have put up their code. Try running that code, think about whether you can rerun it, or go to the code, read it, and see how much of it you understand. And sort of reverse engineer the whole thing based on the theory that we are discussing and your own knowledge of Python. This is probably the best way for you to learn very, very rapidly. Listening to us talk will probably give you only 10% of the actual information that you require to do an actual project. Image data, text data can be converted to numeric data. Can you give an example of how voice data is converted to numerical input? So this is actually a tough question, because this is there is a lot of disagreement even within the literature on what's the right input. But just to put it very, very crudely, the audio data is being stored on your computer. And if it is stored on being computer, it is numerical data. Okay, there is no other way in which it can be stored on the computer. So you can just give that file as a numerical input. Very crudely speaking, you have, you see all these waveforms. Okay, you see all these waveforms for audio. Whenever you run a worst case scenario, you convert that into an image and then run a CNN. Okay, so you can always do that. So that is already numerical data. Another way to see it is see amplitude, frequency, do a FFT of your audio data, and then put that as numerical input into your neural network.
People do wavelet transforms.
Yeah, so you have any number of transforms that you can do from either from raw audio data or even processed audio data. I hope that's helpful. Can a neural network be used as a tool for dimensionality reduction?
Yeah, you can. I think, I don't know whether I have, it'll be addressed in the next few weeks, if not already. So typically what would happen is, so we have not discussed this particular structure. It's called an autoencoder. I urge you to look it up, but I'll be talking about it in the next, last week, I think. So what people typically do, let's say you have a very large image. One of the tools for dimensionality reduction is a pre-trained network. So let's say you have pre-trained image net and you're dealing with natural images. What you would do is you would crop your image to the size of input that the network is expecting, do a forward pass to the network, and consider any of the intermediate layers, or maybe the last fully connected layer if a network has a fully connected layer. And it's called an embedding. And that's what you would take as reduced dimensionality form of your input data. Okay. So think of the fully connected layer of a pre-trained network. Okay. And if you do a forward pass of any of your input, the fully connected layer would be a good representation. You would expect it to be a good representation of your input. Okay. The reason is because your decision layer, which is again just one or two layers removed from your fully connected layer, is depends on this input to classify your data as belonging to one category or the other. So there is some relevant piece of information of your input data that is being encapsulated in the fully connected layer. So typically in deep networks which have fully connected layers, you would consider the fully connected layer as a reduced dimensionality form of your input data.
So this is as an example of this we have actually given in the assignment. An assignment for week 7. You will find this. You can see this in AlexNet, for example. You have a 227 cross 227 cross 3 image whose dimension or number of features is basically 227 cross 227 cross 3.
Yeah.
And the fully connected layer has size 4096.
4096 input. Yeah.
So basically, you have now reduced a large dimensional problem to now a 4096 feature problem. Okay, so that is dimensionality reduction. Somebody has asked for a sample question paper. Unfortunately, you have to treat the assignment problems as samples. So around 25% to 45% will be similar to the assignment type problems.
Yeah. And also, you should look at the lectures and maybe consider the examples. I think Dr. Balaji has given more examples, and material in the lectures are also important. So redo the lectures. It's not too many hours. Yeah.
Somebody has a question on any architecture on images. Which one would you suggest other than Google Colab TPU? Any GPU is good enough. You don't need a TPU. Even CPUs work for certain examples. It depends on the size of your data and the size of your images. Somebody has asked the Stanford course CS231N. Is it beneficial to do with this one? Yes, of course. We encourage all of you to look at as many sources as you would like. That's the way to round off your education.
Yeah.
Whether it is researchers outside or here, everybody looks at everybody's material. Everybody reads everybody's books. Yeah. That's the way to round off, and there is no need for you also to be an exception.
Yeah.
So you will always find something better explained by somebody else. Something maybe hopefully better explained by us. But at a certain time, certain things click for you. So it's always a good idea to look at it.
Yeah.
So same thing repeated a few times actually makes a lot of sense. from different people. That said, the CNN course is a very short course. You will notice it once you start seeing the videos. They have, I think, several years.
Several years. The most recent offerings will be different from the one that got popular.
So we would still recommend the original ones by Dr. Andre Karpathy. They are a little bit more rigorous than the ones that are being dealt with later. At least the few ones that we have seen. They have got very good assignments. Where if somebody wants projects,
they have them. They have them. Yeah,
those are great assignments that you will find there. Okay, you may and you will not find the answers to those assignments directly in the lectures. You basically will have to dig. Each assignment will take you hours and hours to do the coding. Okay, so I think that's a great idea for you to look up what that course is like and what the assignments are like also.
Exactly.
It will give you a good hands-on experience. Yes, XG Boost, is it in scope for our course? Yes.
Yeah,
next week or the week after that?
Week after that. Oh, next week.
Next week we will be covering.
We'll cover boosting.
Yeah.
XG Boost is an implementation of boosting. That's it. We'll cover boosting. Yeah.
So somebody has asked for a given problem, is which one is preferable, CNN or RNN? This was in fact dealt with 2 times. You can see the introduction to the RNN video. When should you use CNNs? When should you use ANNs? I'll repeat this. If you have a pure numerical problem, that is temperature, pressure, stuff like that, very simple, you use ANN. If you have image data, use CNN. If you have sequential data, use RNN. Now, these are rules of thumb. Sometimes you might be able to use combinations of these. The best way to learn, but first cut, if you are finding a problem which is changing in time, try and use RNNs. Okay? Sometimes it's useful. If you are using a kind of problem which can be easily interpreted as an image, use a CNN. In very, very simple cases, use a simple ANN. If the data is, or the number of features is not too many. Yeah. Please give some idea about how to tap pre-trained parameters from existing CNN architectures. You have already done it.
Yeah. So
there's a full lecture on that.
Yeah. Transfer learning, please look it up. I don't exactly understand the question. If you're talking about a programming way of doing it, I mean, it depends on the platform. But if there's a pre-trained network or readily available on different programming platforms, you can just, and there are ways to import that into your current program and use those weights. There are ways to freeze weights in every layer and fine tune and all that. So those are very platform dependent programming. And I think I've addressed that in the transfer learning paradigm.
Somebody has asked about dropout. I thought you had already.
I have talked about dropout also.
Which lecture was this?
This was in the last this week. That is
week 7.
Week 7
in the introductory videos you will find it. So the first 3 or 4 videos.
Or the previous week 6 or week 7. It was
week 8 is week 8 is the one which is going on. The RNN week. The first 3-4 lectures are by Dr. Ganapathy.
But dropouts have been addressed in the previous lectures, right?
Week 7 is it? Yeah. The CNN one.
Yeah, but I have talked about dropouts. Let me just verify which one I'll have to.
Please post this question on the forum. We'll give you a exactly which video this has been
exactly.
But it has been covered.
It has been covered, yes.
For detection and classification of brain tumor from MRI images, can we use CNN? Yes, that's a classic CNN use.
Exactly, and I've talked about that too.
Yeah. I mean,
now you're giving me a lot of doubts. I'm thinking most of my videos are missing. Maybe, maybe you should just tell me if they are, and if they are missing, please let me know, because exactly I've talked about. I mean, it's a CNN that I talk about. Unless maybe you watched that video in isolation, maybe I have not really reiterated the fact that it's a CNN we are talking about, but it is the flow.
Week 6 and 7 is
fully CNN. So if I'm talking about that, it's a CNN. Okay, raising some alarms here. So we'll make sure that we have covered some of the topics in that. Yeah.
One of the students has pointed out that week 7 last lecture was about dropouts.
So dropouts. Okay. Very okay. Thanks.
Thank you for pointing it out.
Yeah. Thanks.
What is this? Can you please suggest any data set to practice simple RNNs? We will suggest a couple. 2 weeks from now, we will suggest that. But it depends on what use you want to put it to. Okay, so if you want language dependent tasks, I had in the RNN lecture, I have pointed out a fantastic blog post by Andre Karpathy called The Unreasonable Effectiveness of Recurrent Neural Networks. He has put up a lot of his own code along with some kind of overall example. Hopefully, along with the videos that we gave, you should be able to figure out what to do. But it's a language task. It will have a lot of specificity. But he has around 100-line GitHub code. That's if you are going to do language related tasks with RNNs, that's a great resource. Please take a look at that. So I would suggest that. Somebody has said that I started machine learning with Keras in Python. I'm confused about learning TensorFlow or not. What do you suggest? Or what do you use day to day, and what do you suggest? Depends on your application.
Yeah, I mean, I think there is Keras. I think is becoming a default kind of front end or for TensorFlow now. So if you're using Keras, it should be fine. And TensorFlow is coming up with a new version, I think,
TensorFlow 2.0,
2.0, which might be more Keras like than the old TensorFlow kind of front end that you might have used. So I mean, it all depends. I mean, lots of people like this PyTorch. Personally, I would recommend MATLAB. We just have to pay for it. That's the only problem. But it's a pretty good resource to have. In fact, if you're part of a university system, university has access to MATLAB. I would just start off with that, and then we'll see how it goes.
Also, it depends on what you want to do. Ideally, use a platform that you are very comfortable with, and until you hit, a wall where you are not able to do what you are supposed to do with it, don't move to a more complex platform.
Another input I would give personally is that initially my students found it very difficult to read in medical imaging data using most of the platform like PyTorch or even Theano and there's TensorFlow. So for instance, MATLAB, it's very easy to read in medical imaging data. Okay, they have DICOM readers readily available. Previously, it was much of a problem. I think some of it is being addressed right now. So if there is a ready-made, easily available platform for reading and reorganizing your data, choose that platform first, and then just to play with it. And then maybe, like you said, once you hit a wall, then maybe you just try out a different platform in terms of processing. So getting your data into your program is probably like it's a big step forward. I mean, that's more important than first.
So somebody has asked, is it possible to use pre-trained CNN for detection of brain tumor, or we should train this CNN from scratch effectively?
Yeah, so since we have been working, there have been multiple challenges that are organized with lots of data, and most most of the networks that seem to do well have been trained from scratch. Okay, it doesn't mean that it won't work, but I have not seen too many people try that out. Primarily because maybe it wasn't working for them. Okay, so if there is sufficient data, I mean, you can train from scratch. I mean, there's nothing stopping you from doing that. But even then, a lot of people suggest that it's just good to take a really large network that has been trained on a very large database and it's been fine-tuned. It's a good starting point always to use a pre-trained network. Some people suggest that. So again, this is at this point the field is such that these things, unless you have a major intuition for these things, the best way is just to try it and see if it works or not. There's no other solution.
Somebody has asked, what is this? Please share your journey in deep learning, machine learning. Hopefully, it will be useful and motivating.
So I mean, so see, for me personally, I started out, I mean, technically among the two of us first. I mean, there's like an year apart. There's nothing. So I see, I work mostly in medical image analysis. Okay, so it's a very applied field. I mean, of course, you can also do fundamental algorithms for medical image. People do that for denoising and all that. So a CNN or these deep learning algorithms was like what do you call an American expression? No brainer. Okay, so this is a picture of your anatomy, the insides of your anatomy. Okay, so it's obvious that it'd be nice. And in fact, if you look at image processing in general, a lot of effort in image processing, either for segmentation, these are the common tasks in medical imaging, standard tasks, segmentation, image registration, and all that rely on feature extraction quite a bit. And these feature extractions were done manually. There are some automated structures available. So when this came along, it was the most natural thing to do. That's how I started it. Okay, so that's how I got into it. And I had some very good students to begin with, and they actually also contributed very nicely to the progress, whatever progress we have, little progress we have made in our lab. So that's what my journey, so called, if you want.
Yeah, I work mostly in numerical methods, so a lot of linear algebra, calculus, etc. So we had been trying to generate in our lab numerical methods for fluid flows. So there are a lot of bottlenecks there. And once I started reading about deep learning sometime in 2015-16, I realized that some of the things could be tried. And this is our basic reason for doing this course also. That hopefully if you have sufficient domain knowledge, you find that certain things require too much of your effort, which could probably be automated in some way or the other. And that's the gap that hopefully deep learning will fill. So that's basically the background for us, which is you will have these things that are very well known in your field and certain gaps that cannot be filled by except for a lot of hand tuned methods. In such cases, deep learning is probably ideal. So that's how I got into deep learning, and then of course the two of us offered this course here.
That's it. I'm almost closing. That's it.
No, there is some video analytics for people detection and extraction. How can I apply CNN for fast computation?
Yeah, so I mean, the people have worked on this quite a bit. So I have not covered it. So maybe I'll just. I mean, it's a regular CNN. The training, data generation, ground truth generation are different. So you should look up, this mask RCNN and something called RCNN. It's not RNN, RCNNs. Maybe I'll try to post a few literature papers in that area. There's also commonly code available, pre-trained networks available for that. So these do one image at a time. So if you give an input image to, let's say, an RCNN or a mask RCNN or any of those things, it'll just give you a box around the object and label for the object. Okay, of course you need to have trained the network that way. Training is very similar to how you train as a network, except that you have to have ground truth data for that. Okay, so ground truth data for training object detection would be you have a pictures, thousands or millions of pictures, boxes drawn on around objects of interest, labels provided, coordinates of the boxes provided, so on and so forth. And you train a network to output the box coordinates as well as the class of the object it detects. Okay, so these efforts have been made in this direction quite a bit. So what they use for video is that you stream the video, you look at every frame and you label the frame. There are now, I think, many of these networks have been implemented which can do, I think, 10 frames or more per second or 5 frames per second, right? 5 or slightly more than that. Real time is kind of possible because people have been trying this on self-driving cars. So they have, instead of having sophisticated sensors, you put a camera up front and it tells you about obstacles, points out lights, traffic lights, pedestrians, so on and so forth. So it's good you asked. We'll try to put out a general announcement with some references to these particular techniques. But they are like training a CNN. There are some tricks, but you should be able to read that paper. I think that's my understanding.
What would be the size of these images? Because the self-driving cars, they reduce the size significantly.
Yeah, so they won't be like, I don't think people are working on like 1024 or your camera kind of picture, right? You have now 15 megapixel cameras. Yeah. They are not you'd be like, I don't know, 200 300 by 300 some, I don't recall exactly, but these are not very large images, so you can't do them real time that fast. So they are constrained by that. So you can't input a 15 megapixel image from your camera and expect it to work. So it's usually like a 500 or 256 by 256, something like that.
There is a question about which frame should they use Google or some such place, where what not platform, what service I guess they should use for executing, let's say, Keras some code. But this really depends on how much you can afford. Each person will say what kind of GPUs they are using and what money they are going to give. Then you have a question of whether this is a reliable company or not. AWS, Google, Floyd Hub, Paperspace, there are all sorts of things. You will have to try. Luckily, all of them give you some number of free hours. The reason for them giving you the free hours is for you to try out your particular application and see if it is good enough or not. So use that hour wisely or few hours wisely and then decide. Yeah, there are some pitfalls there. Be very careful. Some of them, they charge you by the minute, and as long as you are logged in and all that. So once you get into the habit of actually billing only your GPU usage hours and all, I mean, you have to be just pay attention. Don't sink too much money into these things without understanding how these platforms work. So you can try out, like you said, the free hours, get a good understanding of how it works, and then you can put your money where you think it's more worth it. So somebody has asked which software is the easiest to start learning deep learning, MATLAB or Keras or TensorFlow. You have put it exactly in the order which you require. MATLAB is easiest, Keras is next, and TensorFlow is the hardest. Somebody has asked, does correlation imply causation in features in a data set? That is, if features are correlated, then should they be used in training while uncorrelated features are left out? I didn't get the question very clearly, but in fact, what I would suggest is if there are correlated with, which is really why you have dropout also in one sense. But if you have correlated features, the idea would be then you can probably leave one of those out. Just to give you an example, if you are doing face recognition and you have a person whom you recognize, if I show one of their eyes, you can probably guess what the other guy would be like. So that's a correlated feature. But if I show an eye and leave out the mouth, that's actually harder. So if anything, the uncorrelated features is the ones that you should keep. And the correlated features, you can probably drop out a few.
Exactly.
So that's what I would recommend if you are doing simple regression problems. But yeah, this is hard to say a priori, but this is what I would recommend. You should not drop out uncorrelated features, but it's the correlated ones.
So when you talk about binary trees next week, you will see that that particular algorithm actually helps you figure out which one gives you the maximum kind of information about the impact on the final classification. So that's one algorithm that's very useful to know. So that kind of help you address correlation a bit. But like Dr. Balaji said, if you know correlated features exist, it's actually best to leave out one of the correlated features or multiple correlated features, so that you're actually, that makes the algorithm more robust. You should have decorrelated features. That's what PCA also does. Again, we'll talk about it in the later lectures in the coming few weeks.
Somebody has asked, can I train a neural network that decomposes a matrix into two vectors whose outer product is the input matrix? This is a good question. You should try doing it. It'll probably be quite hard. Okay. So you will find that it's probably quite hard. In fact, things that you already know, this is precisely the point that we would like to make. And we will probably make it once towards the end of the course also. Things that you already know how to do and which have an explicit, clear formula, which is sort of compact, are probably the worst kind of tasks for deep learning. Okay. So because it will take a lot of layers to get there and it will not be very precise. Whereas by simply doing a simple multiplication or a simple decomposition, you could do it fairly easily. Okay. So, but I would recommend as a useful exercise to just try it out just for fun and to see how well it does it. To try an ANN on this task and see if it does well or not. What is the level of questions we can expect on the written test? Roughly about 50% of questions would be roughly of the same level as the assignment. And about 50% questions would be, let's say, about 1.2 times harder than this. I'm just making a number up, but something of that sort.
Yeah, so the idea is, you will get questions from the material we have presented, both the lectures and the assignment, which is what, he'll help you boost some confidence when you're writing the examination. You should also expect questions that are slightly off from what,
that is, you need to have not just memorized the material, but need to have thought about it and made connections.
Exactly. And but nothing that would be outside the domain of knowledge that you have. It'll be well within your reach. That's what we are thinking.
Is there an algorithm for feature selection? That is deep learning.
This is deep learning, exactly. Sorry, sir. But that's what I said right now, right? That we are talking about that. See, most of the time, you use deep learning. That, like somebody was asking, how do I reduce the dimensionality of data? The idea is you select the relevant features from your data. Okay. So deep learning does that. That's what you use deep learning for. So you don't have to figure out what the features are. It automatically gets it out for you. Okay.
How do we train our custom-made network on the ImageNet data set? It should be the same as anything else. Yeah. So
you have to split your data in training, testing, validation.
They can actually currently, if you have a custom-made and ImageNet data set has been provided within MATLAB. This is a golden opportunity within the time that the course expires. The MATLAB online account currently you have has access to their deep learning toolbox also. So you can create your own CNN there. Please look up the deep learning on-ramp, which they have given, which is a very good compact way for you to know how to create your own networks. and then train it on ImageNet. They have given an example. You can use.
But you might not be able to use the entire data set. It might be slightly larger, but you can always train on a subset of ImageNet. Right? It's not like you have to do everything. Train on 10 classes. That should be fine. Or 5 classes. That should be okay. Cats versus dogs. That's your favorite example.
Yeah. How can we use machine learning in process design and chemical engineering? We are not chemical engineers.
We wouldn't know.
We wouldn't know. But once again, the same answer. You need to know process design, and hopefully we have shown you all the major models in deep learning so far. You should be able to find out one method or the other which will fit there. And hopefully if you know process design well, and if you know machine learning reasonably well, you should be able to make the connection. This is the same answer for how can I apply machine learning in field X.
Yes. Exactly.
And there is always a way for you to use machine learning in field X. Whether it is a good application or bad depends on how well you know machine learning and how well you know that X. Okay, that should give you, hopefully over these 8 weeks, you should have built some intuition. And if you have not, try applying it in a few problems. Let's say you want to solve a quadratic equation. I give you ABC. Can you use an artificial neural network to find out the 2 roots? Try doing it. You will find it a surprisingly hard task. Okay, so try it only by examples like this. Trying simple things that you already know, will you get some intuition about where should you actually use machine learning and where should you not.
Yes, so that way Kaggle platform is really good. But that Kaggle platform has lots of different kinds of data. But once again, when you use Kaggle data, remember that the data that's provided to you on the Kaggle platform has been well curated. So that's something, if you have domain knowledge, you should be able to do by yourself. Okay, it's curated data in the sense it will be very nice, no errors, properly documented and all that. So, but it's good to try using that data. But when it comes to real world, like your job, your problem you're trying to solve for your business, the data you get will be like all over the place, and you have to really spend a lot of time curating data. So that's a warning I have to give you. It won't be like solving a Kaggle challenge.
So somebody has a question about accessing deep learning in MATLAB. You said you were not able to find it. Please post the question on the MATLAB side of the forum. There is a person from MATLAB who will help you. We have tried it. It has worked. So if you are having specific technical difficulties, one recommendation I have is you post what you have tried so that the people can tell you why it didn't work, if it didn't work.
Yeah, don't feel shy.
Will variational autoencoders and GANs be discussed? Yes. Week 12. If given key value pairs, can ANN be used for decryption? For modern cyber security, no chance whatsoever. Okay, so even if it can't do quadratic equations, it can't do this. And there has to be a functional relationship. The whole point on which, as I understand it, modern encryption is posed is the fact that we don't have a functional form for prime numbers. You might as well ask, if I give you, the first prime number is, let's say, 2, second prime number is 3. If I give nth prime number, can neural networks give that answer? The answer is no. Okay, because we actually do not know what the functional form is, and it's not a simple nonlinear form.
Probably need infinite layers or something. What's the other one? You lost contact?
No. We are seeing it.
Okay.
We are live.
Okay.
Is there any range of accuracy in which our model's predictions should be, so that we know that our model is unbiased as well as not overfitting?
So that depends on the problem. Again, I don't want to give you a statement. See, for instance, given there are some problems which are really hard, okay, and you should be very happy with anything more than the state of the art. Okay, that's how you look at it. So what you can do, if you don't have a very good handle on what your accuracy should be, just go back and look at what other techniques people have tried and look at what kind of accuracy you get. Okay, and if your model gets more than that, that's good. Then you know what that's the range of accuracy you should be aiming for. So it should be better than some very simple technique that's out there. So you can't like really run like a 100 layer network and then come up with an accuracy of 50%. That's kind of doesn't work, right? Then you might as well not do it. Okay, but there are problems where very high accuracy is expected, right? So for instance, in diagnostic tasks, maybe the doctor expects a 99% accuracy. If your model doesn't do that, then it's probably no good. 95 doesn't cut it. So again, that's why I said it's problem dependent. The task at hand will demand a certain accuracy. So whether your model is good or not is whether it meets that accuracy or not. That's all. And can you get it to that point, then you have to look at literature in the sense, what do other techniques do? Do they, let's say you want 95% accuracy on some task and your network does 92, maybe other techniques out there, non-machine learning or some other hand-crafted technique does 90. Maybe it's good. Okay. So, but then you have to do a cross-validation to see that, what is the standard deviation on the 92? Is it plus or minus 25? Then there's again no point. Okay. That's the thing. Yeah.
How to implement this learnings from this course in practically in mechanical engineering? We will show you a few examples in the penultimate week. So week 11, we had actually planned it in week 10, but the unsupervised learning and other material is actually going longer. So we'll do week 9 and 10 will be other traditional machine learning. Week 11 will be full of applications. Week 12 will be GANs and auto encoders. Are game theory and reinforcement learning related? The fundamental goal seems to be the same for both. There are some relations, but reinforcement learning is an entirely different field from game theory. Game theory practically deals only with very, very trivial problems, honestly speaking. Reinforcement learning, the only relationship between reinforcement learning and game theory, it's not even a strong relation, is that reinforcement learning has been used for games. But game theory cannot be used for most games, actually. So, for example, from game theory, you cannot do anything about chess. So, please find one practical relationship between game theory and chess. You will not find any. But reinforcement learning can actually make you win at chess.
Exactly.
So that is, so actually software has one. Game theory is useless as far as that is concerned. Yeah.
That's fine. I don't have anything.
Yeah.
That's fine.
Yeah, I think we are done.
We're done. I think there are only 52. I think number of
No, we are at 6 o'clock.
We're at 6 o'clock. Okay, we are almost there.
Thank you very much. Okay. We might or might not have a session next week, but we'll have one the week after that.
And if you have some questions that you think where I said I provide more detailed, I think I've asked for some questions. Post it in some of the general announcement. Is there a general forum or something? Do we create one or do we create a live forum?
I think we can put an
We can put an announced forum and just like, for instance, somebody had questions about clarity of assignment solution and all that. Specifically, you post like saying, okay, this solution does not clear to me, and we will answer that.
Are not clear.
We'll answer that question. So any other thing, just send a reminder on any of the forum week forums that we have, saying, okay, you said you'll post this, that. You haven't done it, I'll do it. Okay, that's all it is there.
Thank you.
Thank you very much.
We'll have to end the session.